Next up, Itzhak Avraham and Goldshlager about a talk about killing a bounty program twice. Please welcome them.
So hi and welcome to our Hack in the Box talk. Yeah, I'm Itzhak Avraham, and this is near Goldshlager. We are doing the killing a bounty program twice because we did the first one on keto last month, but this time we added additional bugs so we can kill it twice. So I'm Zook. I'm the founder and CEO at Zimperium. Zimperium is an innovative startup that does security for mobile phones. We try to take the current status of security and change it to make the world a more secure place. We recently launched, or a few quarters ago, we launched Anti. Anti is the Android Network Toolkit. We're going to soon launch the iOS version. So keep a close eye on that, and we have actually very good security stuff coming ahead for mobile phones. So keep a close eye on that if you're interested. You can follow me on Twitter. This is my Twitter nick, and on my blog. If someone has any inquiries, feel free to contact me via email.
Hello, my name is Goldshlager. I'm working in the security industry for about 8 years. Today I'm working at Avnet Security Consulting Company. Avnet is one of the biggest companies in Israel. My main job is a web application penetration test. I also found lots of bugs in popular websites, for example, critical vulnerability in PayPal that allow me to gaining access to any finance reports of PayPal users. Today we are going to show you bugs in Google services. We want to show you how any of you can find these kind of bugs. You just need a creative mind to find this kind of bugs. And you can follow me on Twitter, Nir Goldshlager, and that's all.
So indeed, our goal here today is make you think different. So let's say you're scanning some kind of a bug bounty program with the usual apps, the usual programs to scan a website. You would probably not find anything because already other people did that, or the internal teams did the same testings. So you have to check with your methods, well, do different stuff that programs cannot do automatically. So the more manual you go into inspection of each parameters, you'll be able to find more stuff. We'll first do an overview of web application vulnerabilities and well, in our target. Our target in this presentation would be a Google bounty program. After that, we'll do know your enemy. So we'll spy on the enemy. You will see how we get more information about how to find real bugs using some basic intelligence we can use in order to find the next spot, which is weak spots. Once we find weak spots, we'll try to repeat those and try to do it repetitive all over in other services, which will have the same kind of bugs, the same class of bugs. We'll try to do as many demos as possible. In our assessment of this bug bounty program, we found a total of more than 100 bugs. Most of them weren't critical, but some were very critical that can affect any and each one of you directly and without your acceptance. So reasons for bug bounty program. So you first have the money. You get paid for doing research, and the vendor is giving you some kind of basic money for finding those vulnerabilities. The second one is a credit. So when you find a vulnerability, you report to them, you get credit from the vendor. You get the credit page, you get the Google Hall of Fame, you get the Twitter bug bounty program. You get it everywhere. It's written all over, so he has the credits all over. But you know what? Credit is not really interesting because and money is not really interesting because they don't pay much for those bugs. They pay for web application bugs from $500, which is considered a good amount, to $3,000. And in the black market, for example, you can probably find for a Google service bugs much higher than that. But we don't do black market stuff. We are white hat researchers, so we feel it's our need to report, and they can fix, and there's nothing else we can do. But that's the current status. But we are afraid other researchers are not doing the same as we do. So I guess there are other bugs that are not being reported. Bug bounty programs started in 1995 by Netscape, and later on, almost 10 years later, with Firefox. Firefox continued the Netscape methods, so it's kind of obvious that it happened. Later on, ZDI, Zero Day Initiative, started to do the pwn-to-own. Well, they did a bug bounty sort of, so you can report. Until then, you reported to Microsoft, for example, and you got like just credit for who discovered this bug. But later on, they did this sort of selling to vendors, and then they get you paid and give you like bonuses, like flights to Black Hat and stuff like that. They did that, and later on, they did the pwn-to-own contest. In 2010, first Google started to give bug bounty programs for web applications and not just software applications like ZDI and pwn-to-own. Later on in 2011, Facebook joined them and did the same. So now you can find in Google and Facebook, in Salesforce and other services, and you can get paid for finding bugs. But the thing you have to know is you'll not find bugs if you'll just use the normal scanners. You have to do more than that. So the first thing we need to do is know our enemy. Our enemy in this case would be maybe Google. They're not really our enemies. They're in the same building as we are. So we know they can beat us, but we'll be careful with them. So our enemy is not Google. Our enemy is the other researchers. For example, Masato, Kinagwa, Neil Paul, and those guys are finding lots of Google bugs all the time. So if they don't find something, we will find it. And if we don't find it, they will find it before us. So it's a race for time. And basically, you have to find the bugs before they do. Because bugs that already got reported, for example, will get prioritized to them. And you know, you have to, if you want to get money/credit from that, you have to do it first. So you'll have to keep an eye on the others and to see what they're doing in order to maybe get ideas from them and use it on your bug findings. So let's say, for example, they are doing some kind of blog post, for example, about certain vector they found to be vulnerable in one of Google services. You would take that vector of attack and use it in other services. For example, you have someone found a bug in Calendar. Maybe the same kind of vector of attack. If you use it in other service, then you'll find other bugs that weren't discovered yet. So spying on their blog is a very good method to do so. But in order to find original bugs, which is probably more important and more beneficial, you have to learn the company. So you have to find services that weren't checked yet. You have to find services that nobody else has scanned yet, because all of the Google services would be mostly like critically scanned by lots of people internally and externally. If you find small services, services that nobody else touched it yet, then you have more, your chances of finding vulnerability are much higher. So we'll check for successful acquisitions by Google and untested, less secured web applications by Google. We'll try to find multi-vector, which means we'll try to find vectors that are repetitive in other services, which we can use for our benefit in order to find in other services, like I said. So if you want to learn Google, you have to use Google to find information about Google. So you'll Google successful acquisitions. and you'll get the list of acquisitions by Google. You'll get a list of lots of companies. Google is acquiring many companies all the time. So basically they buy a company per week. So every week since 2010 they bought a company, which means a lot of companies that were very fast integrated into their services without really being checked like other internal developed services. So that's very interesting, but we'll keep that to later on. New services are being tested less, like Google Null. I'm sure not much of you have heard what is Google Null, but you'll be amazed on how weird it even gets in other names and other services. So not every service of Google is Gmail or Calendar. So there are small services that nobody even knows about, and they are very vulnerable, and they can harm you in the same way a vulnerability in Gmail can harm you. So it's very important to look for those. Subdomains, they have a specific way of using their convention on subdomains. We can check that. And we can check all the functions that they're using and to see where they're failing all the time, time after time, time after time. And then use it in other services, and you'll find it works very well. So we'll repeat those spots and do that again and again in each and every service. So Google acquisitions, like you can see, since 2010 they bought a company every week. Every week someone said, here you go, take 10, take 50, take $100 million, give me your service. But not every company did the right penetration testing on their products. Not every company put all their efforts on the security. Some companies just wanted to be first. They want to be first, so they develop fast, but you know, security comes later, at second stage sometimes, and then you'll see all the mistakes that the design, the architecture mistakes people did there. So we'll have a certain Google overview, and our approach will be towards mixed and logical issues. Most of the bugs that were found was XSS, but there were also privilege escalation and permission bypass, and well, even something special for the end. So we reveal that later, but you have to understand, XSS is not just about stealing your account. XSS also means I can hack your computer. So basically, when I run JavaScript code on your browser, it means game over, because I can use it to run a client-side vulnerability to, for example, a vulnerability in Flash, or a vulnerability in Chrome, or Java, to use it in order to hack your computer. And only recently, several vulnerabilities have been discovered for client-side attacks, such as Java, that was a logical bug, so every execution of this bug would have been successful. So let's say I'm targeting you and I want to run a script on your account. It's not just about stealing your Gmail. That's not as interesting as hacking your computer. So it even gets easier when you use smartphones. So smartphones are much more vulnerable, and client-side vectors there are the easiest. Okay, so the Google overview, you'll just look at the convention first. So you'll see google.com/calendar, Google Friends Connect google.com/Friends Connect. You'll also see subdomains for each one of them. You can see here in Null, Analytics, Blogger, and other. So the subdomains for those would be the same .google.com. So it's calendar.google.com, mail.google.com. So that's the same for the subdomains. Regarding the convention for the support, you would find almost the same convention for any service. So if you find bugs there, if you see people complaining at the support about certain errors they got, maybe we want to check those errors, because nobody else obviously did before. This is why they got into the support of Google.
So the first bug that I'm going to talk about is stored XSS vulnerability in Google Calendar. Google Calendar is a service that allow to Google users set meetings. They use nicely GUI. Most of us using this service. Google Calendar is a very popular service. First of all, I want to talk about general attacks against Google Calendar. What does it mean, general attacks? It means that most of the people, when they are trying to find vulnerabilities in Google, they just try to inject, for example, XSS in known fields, in a GET request or in a POST request. But if you want to find vulnerabilities in Google Calendar, you must go more deeper. You need to find some places that other people didn't think of. For example, what happened if you delete your calendar, or what happened if you unsubscribe your calendar. If you look more deeper, you can find vulnerabilities in Google Calendar. So the first bug, the vulnerability that I'm going to show you is a stored XSS vulnerability that execute on the client when the victim delete his own calendar. So for now it seems to be only a self-XSS. XSS that only work on my account, because if I delete my calendar, the XSS will be execute only on my own account. So we need to find a way to trigger it for a remote exploit. In the picture you can see that I inject a XSS payload into the calendar name field. Okay, so I create a new calendar and then inject a XSS payload into the calendar name field. And now we see that it's only a self-XSS, because if I inject the XSS into my calendar name, then no one else can access to my calendar, it's only me. So I need to find a way to make it exploitable by using the sharing options. In Google Calendar, you can share your calendar name. What is mean sharing? It means that any user can share his calendar name, and later the calendar will be shown on the victim account. So in the picture you can see the sharing process, and the attacker need to provide the email address of the victim you want to share his calendar name. Okay, so I also found that the user must delete his calendar 1 till 5 times. Why the user must delete his calendar 1 till 5 times for the text to be work on the client? Because after 1 till 5 times the user receive an error message from Google, and then our XSS execute on the client. So we need to force the target to delete our malicious calendars. So we found that there is no sharing limit in Google Calendar. What does mean no sharing limit? It means that any user can share his calendar, for example, 100, 200 times, and the user will get email for each sharing, and the calendar will be added automatically on the victim account. The victim don't need to approve our calendar. This calendar will be automatically added. So we think about a creative way to exploit this issue by using a calendar spam. What happened if I'm sending, for example, 100 calendars to a user? Later, the user see that he have 100 calendars in his own account, and then he start to delete each of them. So after the user delete 1 till 5 times, Google return us an error message with our XSS payload. In the picture you can see the error message and the pop-up of the XSS attack that execute on the client when he decide to delete my malicious calendar, and game over.
So basically what happened is nobody else checked for what happens if I'm deleting a calendar. So probably they did check what happened if you delete a calendar once. What happened if you delete the same calendar multiple times? And actually in Google emails, when you invite someone to your calendar, they say, we have automatically added this calendar to your calendar. So we basically can override all these meetings, and we can actually force him to delete the calendars. So we invite him like 6 times, and then he has all the meetings overridden. He would say, okay, I need to use my calendar, and they are overwriting all my meetings. I must delete them. So we make the user to delete the calendar in order to trigger this error message, which will have the XSS. So that's something like the usual apps or scanners will never find. They cannot find something like that. Okay, so the second bug is Google Analytics. So like I said, client-side bugs are extremely dangerous. So if someone can inject JavaScript code to our client, that's a game over. But what if this someone is in a very critical role in the organization you want to attack? So we know everybody is using Google Analytics integrated into their website, and we can actually check that. You can go to the website and you can do view source. Once you do the view source, you can see the Google Analytics JavaScript code, and you can make sure it's already installed in the website you want to attack. So we entered 2 random websites, I don't know, big websites, big scale websites that uses the Google Analytics. And we see that they're using the Google Analytics service. Okay, that's a first. But we want to attack those websites. We want to attack the owner of the website, not just to hack into his Google Analytics page. That's not interesting. We want to hack into his computer and then hack into his server. Okay, that's more interesting. And we can do that by targeting directly through Google Analytics. So what happens if we find an XSS in Google Analytics? We take full control of the website owner. That sounds like a good plan. So in-page analytics in Google Analytics, for example, doesn't escape the incoming requests. So let's say we're sending a website URL. So you have a victim.com, okay? So you have victim.com, and the Google Analytics doesn't check the website URL. So let's say we are going into victim.com / insert script here. So script alert XSS, you'll do it over there. That's it. Sounds like a very simple test. But okay, Google didn't check the incoming request there. So basically, just by entering a website, you can see here, it's google.com here, but imagine someone from google.com checking this analytics. This is a high-profile website, and it can mean a lot. So basically what you need to do is to escape the web URL, and then you insert your script here. You say, hello Google administrator, and basically just in the URL you're getting into the in-page analytics. So let's say when the administrator logins, that's one possible vector to attack. So we can actively wait for him to log in, and you will never know what we did, because we actively waited for him. We did the attack, and then we wait till he logs in next time to the in-page analytics, and then we basically can hack his computer instead of just hacking the service, which is very important but less interesting in this specific scenario. And the other method we can use that is basically sharing. So we can infect our own Google Analytics, and then we can send someone a link. You know, we gave you a read-only access permissions to our analytics. You would say, what the fuck, why do I have read-only permissions to your analytics? Do I know you? And you can actually click on the link. You will see the link. It's a very innocent link. You cannot see that it runs XSS because the link would be without the XSS itself. Once we shared it with him and send him the link, it's game over. So let's go to the first method. The first method, we go to this URL with the script inside embedded in the URL. Once the administrator log in, we can take full control of his computer. We wait, and that's it. Achievement unlocked. Okay. So this is how it runs. So once the administrator runs the in-page analytics, you'll find that this script runs. So we waited for the administrator. That's a high-profile attack. So it's very critical one. The second one would be sharing with the victim our analytics. So, like I said, we'll share. We're doing you a free will. We're giving you a free statistics about our website, which you probably don't care about. But once you get that invite, you would have to check what is it all about. Why did someone just share his own analytics with me? It must be a mistake. You'll enter that link, and it's game over. So once we share with you the link and send you like a very innocent link, you'll see just a normal link. You can't see any XSS in it. We already inserted the XSS inside, so you're already vulnerable once you enter this link. So that's the second method of exploiting this vulnerability. Thank you.
Okay, so Google Feed Burner is a tool for webmasters to create feeds in their own account. And we also found the stored XSS in Google Feed Burner. In the picture, you can see that the feed title, that I inject the XSS payload into the feed title of Feed Burner. And just create a feed, then call the feed with the XSS payload. And in the second picture, you can see that nothing happened. There is no XSS in Google Feed Burner. You can see the feed title with our XSS payload, image SRC, on error, JavaScript alert, but nothing runs here. So we need to find a way to make this vulnerability exploited. So let's look closer on the features of Feed Burner application. We have a feature called email subscription. Email subscription allows us to subscribe to any feed that we want to. And okay, so we already know that there is a subscription feature in Feed Burner. And what about unsubscribe? What about if a user wants to unsubscribe to your feed? Maybe this can help us to make this attack exploited. So in the picture you can see the cross-scripting POC. When the victim decides to unsubscribe to our feed, Google returns us an error message that says that if you are sure you want to unsubscribe your feed, and then return us the XSS payload. And when the victim will decide to unsubscribe, stored XSS will be triggered on his account. So there is two ways to exploit this vulnerability. One of them is victim subscribe, then later decide to unsubscribe to your feed. And the second one is send a link to a victim. It's important to say that the victim don't need to be subscribed to your feed. You can only send him an unsubscribe link, and when the victim will click on your link, stored XSS will be triggered on your account.
Okay, this is one of my favorites. Again, another service I'm sure not many of you have heard about, Google Friend Connect. So this is another error-based message. Like you have seen in the first two, we use the sharing option in order to find vulnerabilities there. So it probably means the sharing option wasn't checked that properly in all of the Google services. Just saying, you know, maybe next time you want to share something, think about it. So Google Friend Connect, this is my favorite because it involves a bit of social engineering. You probably have seen many hot girls adding you on Facebook recently with no any mutual friends and basically no other friends. So just a bot or something that has a very nice picture. So the attacker would have a very nice hot picture going to the victim and say, hey victim, let's be friends. And the victim would probably say, okay, this is a hot girl, what can I do? let's add her as a friend. I mean, she wants to be friends with me. I don't know why, but I will add her, and I would know it would work on 99% of the males in this room. So even if it's a security conference, you know what? Especially if it's a security conference. So although we know the risks about adding hot girls to our Facebook or Google Friends Connect in this scenario, we still do add those. And the target will approve our request. The target will approve our request, but we added it as a nice name. We had a nice name. Our name was Alicia something, or I don't know, you choose some kind of a normal female name. But after we finish that, we want to make him delete us. We want to make him to not be happy with our relationship. So once he finds out this is not a real female, he would probably want to delete it. But we must encourage him, because people are not using the delete option as often as you would imagine. So it can be very easily, for example, if you're using Facebook, I'm sure you've added lots of friends or people that you call friends, but you never really unfriended with someone. So if you're unfriended with someone, it must be like a real big deal in order to remove him as a friend. It's like a message. I'm removing you as a friend. You're not welcome anymore. So it's not something you do in your daily life. We must force him to do that. So we will spam him. But once we do that, we'll like make sure he's not very happy with our relationship at all. So we will spam him as much as possible in any way. But before we do that, we'll change our name. We'll not be Alicia or some kind of other female name anymore. We'll be Script Alert XSS name. So we'll change our name, and then we'll make him hate us in every possible way until he unfriends with us. Once he unfriends with us, then he will go to this screen. He will not see the whole, like you can see, he will not see the whole name. So that's good for us. But once he clicks remove as friend, it's game over and it's another achievement unlocked. So don't friend with people you don't know. That's the... Thank you.
Google Null is a web service that allows users publish their own documents. Most of the users of Google Null is medical users and research users, and it's an online knowledge portal. In Google Null, you have two privacy options. One is a published document. It means that every user can access to your published document. And the other one is unpublished document. Unpublished document means that your document is private. Only you got access to your unpublished document, and no one else can access to them. In the picture, you can see the process of unpublished document. A user write his own document and then decide to unpublish. And in the second picture, you can see that if someone else trying to access to your unpublished document, you receive a message from Google that says the request null is currently not published. It means that the document is private, only you can access, and no one else can. Okay, so Google validate our permission. They denied us from viewing the unpublished documents. So what can we do? We need to find a creative way to bypass the permission validation of Google. Let's meet our new friend, Google Null Translator Toolkit. Google Null Translator Toolkit is a tool that allows users translate their own documents. You just need to provide the URL of the specific document that you want to be translated, and upload it to the translation tool. In the picture, you can see that the attacker provide the URL of the unpublished document and then upload it to the translator tool. And let's wait and see what happens. Okay. So in the picture, you can see that the translator do the job for us. The translator access to the unpublished document because Google Translator tool have permission to access to any document in the application, and they didn't validate that if the document is published or unpublished. So I use the tool of Google Translator to access any unpublished documents in a Google null service.
Okay, so probably Google Null is another service you didn't know that was existed. Okay, Google Affiliate Network. This is more a common service. So I know more people that uses it, but maybe it's because the people I know are different. So Google Affiliate Network stored XSS and administrator privileges. So we'll do the both, but they're actually very well connected to the same bug. So we will see it now. So what is Google Affiliate Network? That's a very good question. They gave us the answer. Google Affiliate Network is a free program that makes it easy for website publishers to connect with quality advertisers to get rewarded for driving conversations. So we are actually doing a commercial for Google here. I'm sure they don't need us for doing those commercials, but this is what the service does. And we'll use it to bypass those permissions. We'll use it to do whatever we want in their service. So, first of all, our goals are, we have two different goals. We have an XSS an account, so we can basically not just steal his account. Stealing his account is not much of a matter once we have the second goal, which is gaining administrative privilege on his account. So we don't need the XSS to actually steal his account. But we can use it to hack his computer, so that's good. So like I said, Google has acquired many companies, and like you can see here, the website that is here is Connect Commerce. Connect Commerce was actually part of Performix, which was acquired by DoubleClick, which was acquired by Google. So Google has received a bug from DoubleClick that received a bug from Performic, and nobody checks it in the way. So basically the first attack is very simple. We change the link ID, and once we change the link ID and we are already authenticated, we can see other people's links. Once we do that, we can change. So this is a permission issue basically. But once we can change someone else's link, we can also change someone else's text within this link. Once we change that text within his link, we injected an XSS to his account without his knowledge. So the permission issue was elevated into, or downweight, or the other way, to an XSS. So this is basically a permission issue and not an XSS, but this website was so vulnerable that you could have also seen a real XSS in his account. So the first one would be manipulating parameters on connectcommerce.com domain in order to inject the XSS payload on google.com domain. So once we change the link ID and use our partner ID, or we can change the script, the text there to have a script, and basically game over. Once he connects to his account, that's it. So this is the first POC for this website. The second attack is actually more effective. Why hack into somebody's account via an XSS when you can directly access his account? That's even better, right? So manipulating the parameters in order to get administrative privileges on any Google affiliate account, that sounds like a very good jackpot. So you can basically manipulate the user ID so once you want to change someone's email and you're already authenticated, then someone had thought, oh, it should be okay if I can update someone else's email or account to my email. I don't know why. It thought I was okay. It looks like an architecture design bug, but it thought that should work well, probably, and it did work well for us. So once we use his account ID and we change it to our email, and we're already authenticated, then the server would say, okay, I'm allowing you to change your account to my email. And they thought that would be cool, so we did that. And that was a game over for them, and that was an elite vulnerability, so this was considered a good one among Google. Thank you.
Okay. Google Picnic service. Google Picnic service is like service like Instagram service. Did someone heard about Instagram? It allows you to edit your photos online. They use a photos GUI, for example. You can make effects on your picture, and you can edit it online. Google Picnic service is a part of Google. It's hosted on Google services server, and it's one of the most popular services in Google in a photos service. Okay. If you look in picnic.com, you see that the application is kind of secure. What does mean secure? It means there is no issues in picnic.com. If someone trying to find vulnerabilities, you only see flash files on the server, for example, and he can't inject any malicious payload. So it seems to be secure. So we need to find a way to crack the application, to find a way to hack the Picnic server. So we start with a brute force attack. In brute force attack, you can also brute force for files. For example, if you want to find the new files on the service that you are going to check, you can find the new directories with a brute force. You can also perform a brute force attack on our subdomains. For example, b.picnic.com, e.picnic.com. So you can use the brute force attack to find the new subdomains in the server. And also a port scanning. You can scan the IP, find some new ports, and that's all. So we found that there is a subdomain called vpn.picnic.com. This subdomain, I think that no one is using it in Google. I don't know why this subdomain is alive, but we found there is a PHP application on this subdomain. But first of all, we just pinged the VPN to see on which server picnic.com hosted. So we saw that picnic.com hosted on a Google server. In the picture you can see that it's hosted from in a Google. So what was the story of the VPN Picnic? It seems that someone installed by mistake an older version of PHP List. PHP List is an email application. PHP List also suffers from a lot of vulnerabilities, critical vulnerabilities. And okay. We also found that they use PHP List with a default username and password. It was a very big mistake. And we also found that PHP List is vulnerable to a local file inclusion. Local file inclusion vulnerability allow us to get a shell on Google server, take full control on the server. You can see that it suffers from well-known vulnerabilities. local file inclusion, SQL injection you have in PHP list, XSS, all the web attacks, I think. So the person who installed PHP list, I think he got fired because it's, to be honest, I was kind of surprised to see that there is a PHP list application on Google server with a default username and password. And in the picture, you can see the POC of the local file inclusion on a Google server. You can see that we get a shell with a lit bounty, 3133.7. It's the most higher price for bug findings in Google service. And it seems that the picnic is over. This is the POC email that we get from Google, that we determined that this was exploitable and could have led to a full server compromise. And that's all.
So you would probably imagine that if you want to hack into Google, you'd have to use 0 days and send them via email and be named as the Chinese government. But you can actually find like a vpn.picnic.com and hack to that through that to google.com with the default username and password. So what we want to say first is we love Google. They are I think they're doing a great job, and we reported all those bugs, so we didn't actually release any vulnerabilities to the public. It's very important to us that no one will get hurt from those vulnerabilities. So we work with Google, not against Google. And they have bigger guns than we do, so we don't want to make them upset. But we're good friends. So in order to hack into Google, you have to do several stuff. Or not just Google, but any bug bounty. So this was just an example of just a big bug bounty program that has multiple servers, multiple services, multiple extensions and whatnot. It's like a very big company, so it's just a very good example for a bug bounty program. But we could have done it in any other company. So if you have a big company and you have a lot of mess, you should start reorganizing that stuff, because you don't need a 0 day to hack into a company. You only need a default password to hack into your company. That's all it takes. So protect against that. That's very important. So in order to find bugs in those services, as you have seen, it was always the same issues. It was unsubscribe button, it was the sharing option, and it was other options that are very repetitive in all the services. So you wouldn't find bugs in the normal one step to the application. You wouldn't find bugs in the calendar name if you just do it, I don't know, what with that. But if you share it with someone, then it would take a whole different scenario nobody else checked before. If you go through the path nobody else checked before, then you might have a chance of finding a really good vulnerabilities, and a lot of them in a very short time. So that's very important. You have to think different. Information gathering is also very important. So like you have seen the acquisition stuff. If you get some more than just the basic information, it's all out there. It's all open. I mean, it's all in the internet. You can use Google to find information about Google. That's very, I like it. So mixed services. So once you share with one service to another, you get like they're doing you a favor. We automatically edit his calendar to your calendar, for example. Thank you. That was very good for me that you did that. So mixed services is also a good spot to look at. And permission bypass. You can see in multiple services that the permission was not properly checked. That actually, you can see that in lots of companies. So if you're having permissions in your web applications, you should take a deeper and closer look into that, because that's not something the usual scanners would find, because they cannot, basically, or not that easily. There's some reference to some links you might want to check out later. And we might have one more, so it's not over yet. Maybe, just maybe, it's not a good idea to follow our blogs, because this what can happen to you. Okay. You want to do this one?
The last vulnerability is HTTP parameter pollution in Blogger. This vulnerability allows me to gaining administrator on any Blogger account. Most of you heard about Blogspot, WordPress. So Blogspot and WordPress is the most popular blog services. And in this video, I'm going to show you how you can be administrator of any Blogger account.
Okay, so we didn't put it ahead. It will take like 30 seconds to prepare, so please forgive us ahead.
Okay, in this video, I act to a Zook blog. To his own blog. Okay, so in Blogger, every user in Blogger have a user ID, a Blogger ID. I mean, it means that me is, for example, blog ID 1, and Zook is blog ID 2. So every user in the Blogger service got his own Blogger ID. So in Blogger, I found that if a user provide duplicate fields. What is mean duplicate? Is mean if you have, for example, in the post request blog ID 1, and I duplicate the field with another blog ID until, for example, blog ID 1 and then blog ID 2. So the server see the blog ID 1 and they say, okay, it's secure, blog ID 1, but instead it's execute the other field. So, for example, blog ID 2. So in this kind of manipulation attack, I was able to bypass the permission checks in a Blogger service and becoming an administrator of any Blogger account. Now you can see the post request. I just duplicate the blog ID field with one more blog ID value. This is my own account, okay, with my own permission. Now I'm add a user to my blog to give him a permission and intercept the request to modify the request. So in the request you can see there is a blog ID with a value 210333535 and at the end 02. And now I duplicate with another blog ID field. This blog ID is the blog ID of Zook, okay? Zook also have a user in a Blogger, so I provide a blog ID of Zook. And after I modify the request, I send the request to the server. Now let's wait and see what happens. So now I'm logged into my Gmail. I need to get a notification that someone has been added to administrator. Just need to provide my own password. Now I'm added myself to a Zook blog with other permission. But, yeah. And now the second step is to be administrator of Zook blog. So let's see. We intercept another request and manipulate the blog ID value, duplicate it. This is the original request, the post request. This attack is kind of complicated, but if you get the idea of how to use this kind of tricks, so it's more easy to understand. But okay, so now I'm in a Zook blog. Now I want to make me administrator, so I may intercept the second request. But first of all, I need to find another value, the member ID. Everyone has a member ID, so I need to retrieve the member ID of Zook before I'm doing the admin attack. Now I'm changing the values. Okay, so now I have a URL with the blog ID of Zook and the member ID of Zook. Just need to send it to the server to see what happens. So you see there is a grant admin privilege. So now I replace my blog ID with his own, with the Zook blog ID.
So now he has granted permissions to himself for my blog, not to his blog.
And let's send this request to Blogger server. Okay, so now you can see that I'm the administrator of Zook blog. You can see in my test blog that Zook blog has been shown in my own account. So okay, now I can edit his blog, delete his blog post, do everything that I want. I've got access to all the options in his Zook blog, and that's all.
Okay, so we'll go back. Tonight we're having a small event, Hacking the Empire. So it's a limited event, so if you want to get an invite, just send us this email. Thank you very much, it was a pleasure. Anyone has any questions?
Guys, anyone want to have some questions for him for this good presentation?
I just wonder, how do you work? Do you work alone? Do you work together? Is it what happens to make these ideas pop into your head? That the ideas pop into your head to make these strange.
Okay. Basically, Nir started this whole project doing assessment on Google, and I joined him for some stages of this research, and we tried to find, instead of just attacking certain stuff, we tried to think ahead of what other people never had thought of. What functionalities, we mapped the functionalities, we saw what functionalities nobody else is ever using, like unfriend or sharing. So that's how we did it.
Questions?
Thank you.